Okay, second part of doing problems. Let's take a look at number 11, blood. Only 4% of people have type AB blood. On average, how many donors must be checked to find someone with type AB blood? Okay, so how many donors must it take, or really, what's the expected value for finding someone who is type AB blood? So this is what I know. I know the probability of success is 0.04. Geometric formula for the mean is 1 over p. So the mean is 1 over p, which would be 1 over 0.04, which is 25. Now, did I do that in my head? No, I just remember. Okay, but here's what we should also think about. When we're talking about a normal model for this, what we said is that the mean of a binomial distribution is n times p, number of trials times the probability of success. And I said in our example is that if you were going to flip a coin 20 times, how many heads would you expect to get? And what you could do is you could take, I could take the number of flips, which would be 20, times the probability of 0.5, and say, 20 times 0.5 is 10. And I could do the exact same thing. I've said, okay, say that pulling a blue M&M, the probability of pulling a blue, I didn't start this again. Probability of pulling a blue M&M is 30%, and you've got 100 M&Ms in this bag. How many of them should be blue? You'd say, well, if 30% of the M&Ms are blue and I've got 100, then 100 times 0.3 would be 30. 30 of them should be blue. So that's what we're doing. We have the exact same thing. So here's what we're going to say. We're going to think about this the exact same way. I'm going to say, okay, n times p is the mean, and another word for the mean is the expected value. How many I should get. But what I'm asking here with this question is, how many people with a probability, of 0.04 would I need to get an expected value, or to get my first person with type AB blood? So what I'm looking for is I'm looking for my expected value to be 1, to find my first one. So I've got n times 0.04 is equal to 1. So how do I find n? I divide both sides by 0.04, which is what this is, 1 divided by 0.04. So n is equal to 1 divided by 0.04, which is 25. So that's actually how this comes about. But I don't need to memorize that formula. I can just think about it as being mean or expected value, but my expected value is going to be 1. All right. What's the probability that there is a type AB donor among the first 5 checked? Which means I could have it be in my first person, which would be success, or my second person, which means I'd have a failure and then success. Or it could be my third person, failure, failure, and then success. Or my fourth person, failure, 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 and success. Or my fifth person, failure, 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 and success. Which we did last time with the making the shot in the last problem. And I could find all these probabilities and add them together. Or what I could do is I could sit there and say, we said that this is like an at least one statement. So at least one is the complement of none. So what I do is I find the probability of having 5 failures, failure to the 5th power, and I subtract that, because at least one is a complement of none. Well, here's none. Okay? What this means, I'm having none people type AB blood. So failure here is 0.96 to the 5th power, 0.96 to the 5th power. 0.96 to the 5th power is 0.8154. So I would do 1 minus 0.8154. And I get 0.1846. All right, number 6. Or number 6, yeah. C says, what's the probability that the first type AB blood donor will be found among the first 6 people? Well, you know what? What I could do is I have the probability among the first 5th. I could actually just find the probability of the 6th, which would be failure, 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 and then success, which would be the 6th. And I can find that value and add it to this, and that would give me my result. I don't know if this is clear. Or I could just do 1 minus the failure of 6 just like I did for 5, and I could get that answer. Okay. D, what's the probability that we won't find a type AB donor before the 10th person? Which means what I'm looking for is I'm looking for my first success to happen on the 10th. Or it could be the 11th, or it could be the 12th, or it could be the 13th. So I would need to add all those together. But if I think about this, and I say, okay, my first success has to happen on the, can happen on the 10th. What has to happen before that? Well, what that means is I have to have 9 failures. So that's exactly what this question is asking. It's saying, what's the probability I'm going to have 9 failures? Which would be failure to the 9th, or 0.96 to the 9th. And you can figure that out all by yourself. All right, 13. Still on page 399. Well, yeah, because we are. All right, lefties. Assume that 13% of people are left-handed. And it used to be that left-handed people were signs of the devil. And if you know someone left-handed, and you don't like him, you could say the exact same thing. So, assume that 13% of people are left-handed. If we select 5 people at random, find the probability of each outcome described below. A, the first lefty is the 5th person chosen. Okay, so if the first lefty is the 5th person chosen, that means that I've got a righty, and then a righty, and then a righty, and then a righty, and then a lefty. Okay, which would be righty is 0.87. How many do I have? I've got 4 times a lefty, 0.13. 0.87 to the 4th times 0.13, and we get a value of, or we get a value of, I hate when my calculator breaks, or we get a value of, or we get a, let's see if it works with the trackball, or we get a value of, and you know what, it's just not gonna tell us. So we get a value of, wait, I have it written down here, 0.0745. This is really gonna be a bummer because I do need this thing to come back. That's broken. Come back. Oh, it just closed. All right. So let's take a look at the next question. Hopefully this will come up. It says, there are some lefties among the 5 people. What does some mean? Is there a specific number for some? No. Some means at least one. At least one. So it could be the first one, or it could be the second one, or it could be the third one, or it could be the 4th one. It means at least one. And how do I find at least one? At least one is the complement of none. So what's none? None would be all right-handers. All right-handers would be 0.87 to the 5th power. And so I do 0.87 to the 5th power minus 1, and your answer, because we can't see that, there is 0.5016. Come on, calculator, come back. Come back. All right, 13. The first lefty is the 2nd or 3rd person. Okay, so what does that mean that the first lefty is the 2nd or 3rd person? That means that I could have a righty and a lefty, or I could have, and see the calculator didn't come back again, or I could have a righty and a righty and a righty and a lefty. The third, I went to second or 3rd, right? Did I mess this up? Yep, okay. Don't do that. So, it's not righty, 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 lefty, it's righty, lefty, or righty, righty, lefty. Okay, so this is 0.87 times 0.13, or add 0.87 squared times 0.13. Make sure that you can see that there. And we get an answer of 0.2115. Oh, good, the calculator's back. Let's see if we've lost everything here. So it's 0.2115, and that part there is just incorrect. Okay, you know what? Do we have time to go on? We do. All right, so there are exactly 3 lefties in the group. So exactly 3, now think about this. This is, of 5, you have 3, and this starts now being binomial. Binomial means that what you have is you have a set number of trials. We have a set number of trials of 5, and we're going to look for exactly 3 of them. So we'd say, oh, this is 5, choose 3. Now, the binomial formula was this. It was n choose k, where n is the number of trials and k is the number of successes, times the probability of success to the number of successes power, times the probability of failure to the number of failures power. What you are expected to do is to put these values in place as the values themselves here in the formula. Not writing the formula like this, but with the values, okay? So I've got 5, I'm expecting exactly 3 lefties. So 5 choose 3, probability of lefty is 0.13, number of successes is 3, and what we said is that this value here for the choose, number of successes, and the exponent for the probability of success is going to be the same, 0.87, failure, complement of success. 2, I have 2 failures because these 2 exponents need to add to 5. So I have to write this. Okay, I hear you. I hear you. We're almost there. So that's what I need to write. At this point, I can use the calculator to get my result. How do I do that? I go to the distribution menu and we look for binomial PDF, because binomial PDF means exactly. So I'm going to go to binomial PDF. Syntax NPR, or K because the calculator is the only one that uses R. N, number of trials, is 5, comma, P, probability for success, is 0.13, comma, number of successes, 3, and these are the numbers you're using right here, N, P, R, or K. We hit enter, and we get 0.0166. Okay, coming back, we're going to finish this problem, we're going to come back.